Hello everybody, and welcome to this first online public event from the Future Battery Industries Cooperative Research Centre. I'm Miriam Stanborough. I'm the Chair of the Minerals Research Institute of Western Australia, and I'll be hosting your event today. The Future Batteries Industry, CRC, is enabling the growth of battery industries to power Australia's future and ensure Australia plays a leading role in the global battery revolution. The Minerals Research Institute of WA is a key participant, contributing $6 million of WA state government money over 6 years, of which $500,000 is contributed from the WA Department of Jobs, Tourism, Science and Innovation. The Minerals Research Institute provided funding for this scene-setting report and for the flagship cathode precursor pilot plant project, which is a subsequent piece of research. This investment by the Minerals Research Institute of WA is one of the key action themes in the state strategy and is instrumental in positioning WA to deliver on the aspirations contained in the strategy to take WA beyond being just a supplier of battery minerals and instead being a producer of battery materials and move further downstream in processing our minerals. As the second largest cash contributor to the FBICRC, second behind the Commonwealth Government, the Minerals Research Institute is focused on ensuring the work of the FBICRC delivers benefit and value to WA and as a result of the research it undertakes. I'm joined by three panellists today who are joining me here in Perth, and I also have one in Queensland. I would first like to introduce Professor Peter Klinken. Peter began his tenure in June 2014 and is West Australia's third Chief Scientist. He has since been reappointed 3 times and his tenure continues to June 2022. Peter has brought a wealth of knowledge and expertise to the role of Chief Scientist of WA, providing independent expert advice to the state government. He has supported the government in growing the state's science industries to achieve future prosperity for West Australians, as well as assisting with changes to legislation. Peter is passionate about issues for Indigenous peoples and ensuring that the education system provides opportunities for everyone in a rapidly changing world. Peter was appointed a Companion of the Order of Australia in 2017. He was West Australian Citizen of the Year in the Professions category in 2008 and made a Fellow of the Australian Academy of Health and Medical Sciences in 2015 and a Fellow of the Australian Academy of Technological Sciences and Engineering in 2016. In Queensland, and joining us online, is Professor Peter Talbot. Peter is internationally regarded as a materials science expert and leader in the fields of lithium-ion batteries, nanomaterials manufacture, and high-temperature superconductors. He holds numerous patents and has been co-founder, CEO, and director of several successful high-tech startup companies. Peter has jointly established product development with more than 50 international companies. He is currently coordinating projects which will extend battery manufacturing and testing facilities in Australia. Peter is currently a Professorial Fellow at QUT, an AQ Founders Fellow and a Program Leader for the Future Battery Industries CRC. He is also a Chief Investigator of the ARC project for future energy storage technologies and the ARENA program for renewable hydrogen production. He established QUT's Advanced Battery Facility, Australia's first lithium-ion battery manufacturing plant. Welcome, Peter, from Queensland. And back here in Perth with me, I also have Gary Frampton. Gary is BHP Nickel West's Head of Business Development and Technical Projects. Gary has played a significant role in the transformation and reorientation of the Nickel West business from being a supplier to the stainless steel sector to becoming a globally significant battery materials supplier. Prior to his appointment, Gary held numerous senior leadership positions across the Nickel West asset, including General Manager of the Kalgoorlie Nickel Smelter and Kambalda Concentrator, and General Manager of the Kwinana Nickel Refinery. In prior roles with Anglo American and Bulong Nickel operations, Gary held numerous senior engineering and technical positions. Welcome, Gary. So before we throw to Peter Talbot in Queensland to present the findings from his research, I would like to ask Peter Klinken to provide an introduction and his thoughts on the research. Thank you, Peter.
Thank you very much. Can I start off by acknowledging the traditional owners of this land that we're meeting on, the Noongar people, in their language, a language that's been spoken around here for 65,000 years. Kai Nunakot, Ninja Burlu, Ninchkarich Noongar Birdie Mum and Birdie Yoga, Kura Kura, Waya Yay. This is the land of the Noongar people. Hello, everybody. We're meeting in the Perth CBD, which was called Burlu. Look, this is an incredibly exciting time. We're going through Industry 3.0 and 4.0 simultaneously, the third and the fourth industrial revolutions. The world has never changed at a faster pace. And with each of the industrial revolutions, and I was one of the few people who was around for the first industrial revolution. It's a joke, okay. Sorry. When we changed from wood to coal, the second industrial revolution involved moving towards oil and gas, and now we're in a period where we're starting to look very seriously at renewables. And Western Australia in particular has got this incredible plethora of opportunities through solar, wind, Perth being the second windiest capital city in the world, and opportunities through geothermal, tidal and wave power in the future. But coupling all of that, most importantly, is the ability to store renewable energy, and that's through the incredible advances in battery technology. So Western Australia is unbelievably blessed, in my view, to have lithium, nickel, cobalt, aluminium, vanadium, zinc, manganese, iron, graphite, you know, all the elements necessary to make lithium ion and future batteries. You know, the graphite has not been tapped into yet in Western Australia, but we also do have a company called Hazer that makes graphite by cracking methane. So all the elements are here to make lithium ion and future batteries. The state has made it very clear that it wants to go further downstream and look at exploring the value chain. And I think this has been incredibly well led by Minister Bill Johnson, and there's been very clear signals that the state is exploring these opportunities going down to processing that we're going to hear more about, electrode components, potential cell manufacturing, assembly, which is already happening here in Western Australia, and even recycling, which is happening as well. So these are exciting developments. It's a very important time, particularly in this COVID period where global supply chains have been disrupted enormously, and everyone's looking to see, well, how can we do things differently? How can we do things better? So, I hate to sound like a crack record. I am excited by this. I would love to see Perth become what I call a destination city because it's safe, it's green, it's clean, it's secure, particularly in this COVID period. There is very low sovereign risk here in Western Australia. It's well regulated, it's incredibly stable. We have a tolerant multicultural society, and we have a very capable workforce. And you know, if you were in North America or if you were in Europe, you'd call Perth a university city because there are 5 universities here in Perth. So I think we have all the ingredients to make Western Australia, and Perth in particular, a centre for battery technology, current technology, as well as future technology. It's a moment when the state has really is exploring the opportunities downstream, and you know, cathode active materials is very much on the agenda right now. The state government is exploring these opportunities, so I'm really very, very keen to promote these ideas and to see how far we can go down the value chain.
Thank you, Peter. That's a great introduction. We will now ask Peter Talbot, Professor Peter Talbot from QUT in Queensland, to take us through the details of the research that he conducted. Peter, over to you.
Thanks, Miriam. Thanks for that introduction, and Peter for that great lead up. I think I need to become an honorary West Australian after hearing that introduction. What I'd like to talk about is something that we're all becoming very aware of course, and that is the growing use and application of lithium-ion batteries in our lives. It's in energy storage, communications, transport, and the rate at which this market is emerging. It offers a huge opportunity for Australian resource companies, and that's where I'd like to, if I can, provide you with some of the details of the scene-setting report for the manufacture of cathode active materials in Western Australia. I'll just begin a presentation to share with you. So in this presentation, I'd like to look at simply to start with, what is a cathode active material and how it might affect a growing expertise, employment, and investment in Australian battery sector opportunities. The scene setting report at the centre of this research was commissioned by the Future Battery Industry, CRC, and the Minerals Research Institute of WA. The research was undertaken in collaboration between QUT and Hatch Engineering. The report intended to look at and assess the technical and commercial feasibility of establishing precursor manufacturer in WA. And the first thing that the report found was a number of groups are already advancing from raw materials to battery grade chemicals, and particularly in Western Australia. So those sorts of minerals such as cobalt, nickel, manganese, and lithium, the rewards were up to 10-fold increases, we found. Now, I can only present you with a summary of this report in this presentation, but I'd encourage you to go to the Future Battery Industry CRC website and download the link for the full report, and there's quite a lot of detail there for those that are interested. But if we look at the opportunity first, before we go to just exactly the detail, here's an indication of what's available in terms of the lithium value chain. If we look at this graph, and we see around 2017, mine concentrates were supplying over $1 billion of resource back to Australia. But at that time, the rest of the value chain, we were not participating, and it was a market of around $156 billion. Now, forward projections to 2025 show that if we continue down this path of just exporting our mine concentrate, that we're likely to bring in resource dollars of around $10 billion, while the rest of that battery chain is going to deliver $1.7 trillion. And I have to say that these estimates are growing daily. So there's a great opportunity here for Australia. So the first question is, well, what is inside a lithium battery? We talk about a cathode active material, but we probably need to identify just what it is. So the cathode active materials are actually a powdered material. In this slide on the top right-hand side, you can see that it's a black powder. The black powders are typically turned into inks by using binders and solvent and coated onto electrodes. The electrodes are rolled with separators, and you see the familiar form of something which we call an 18650 battery. It's something similar to a AA, and it's the lithium battery that we're familiar with, or even if you haven't seen it, it's the sort of thing that runs a Tesla car. So we're really interested here in the highest value portion of the lithium battery, which is a cathode active material. Just a quick recap on how these batteries work. There are three main sections of a lithium battery, which is the cathode, which stores the lithium and releases the ions when the battery is charged. The electrolyte, which is the liquid that transports the lithium ions to the anode, which is the third part. It stores lithium and it releases the ions back when the battery is discharged. So the cathode and its coating on the cathode active material that's coated onto that electrode is where we're interested in. Now, typically this material is lithium metal oxide. So it's a combination not of just lithium, but lithium in a compound. So if we consider then, if we're looking at an opportunity for manufacture, what's our choice? What's our choice of cathode? And we have a matrix here which we look at to determine which cathode will perform the best for which application. The sorts of things we look for is specific energy, specific power, safety and performance, but also cycle life and cost. Now, there are a number of standard cathode materials we can consider. And if we look at how those properties fit together in this matrix, here's an example of a compound which is lithium in combination with iron and phosphate, lithium iron phosphate, as a battery cathode active material. It has good specific power and safety, but its energy density is lower than some others, and its life cycle is also quite good. So this is a choice which is commonly used. Another option is lithium manganese oxide, and as you can see on this diagram, the cycle life and performance is not quite as good. Lithium cobalt oxide has very high specific energy, but its safety, cost, and performance are below some of the other options. One of the compounds that's typically used in vehicle applications, electric vehicles, is a compound called nickel, it's NCA, and so it's nickel cobalt alumina. It has very high specific energy, it has fairly good performance and cycle life, but its safety is still an issue. So one compound which is our potential compound of choice here is NCM. It's a combination of lithium with nickel, cobalt, and manganese. And it has all-round good performance, safety, power, cost, and life cycle. So using the simple matrix, we can choose which material we prefer to use and develop. So NCM is our material of choice. So if we look at it in some more detail, our precursors for mixing and making this lithium, nickel, manganese, cobalt material are the metals. But we can't mix them as metals. We need to know what sort of precursor we would use for this production. And in the case of the cobalt, nickel, sulfate, nickel and manganese, we'll use sulfates, and for lithium, hydroxide. So we now need to consider the battery grade of these materials that we will use. If we go through them, cobalt, we're expecting a 99.98 purity as a minimum as a precursor material. At the moment, around 57% of cobalt is used in batteries that's mined, and 37% of that is as sulfates. And if we look at this diagram, we can see that Australia is the second largest producer currently of cobalt after the Democratic Republic of Congo. Nickel is the primary precursor in these materials. So it also has a minimum purity of 99.98%. And in 2019, there was about almost a million tons of this material produced. But the projections are for a rise and increase in this material on the basis of the NCM cathode material being introduced, particularly the nickel-rich cathode compositions. If we consider the composition in terms of NCM, nickel, cobalt, and manganese, we can look at the relative ratios of the amounts of those materials, and that's how the nomenclature we use for identifying. For example, NCM 811 is 8 parts of nickel, 1 part of cobalt, 1 part of manganese. The manganese at the moment is the global production is estimated around 28,000 tons, but 87% of that is actually produced by Chinese suppliers. Again, the purity is around 99.98% minimum for battery grade. The lithium that is at the core of these batteries, of course, again is high purity. We have to be very careful about impurities, but Australia has now emerged as the largest miner of lithium in the world, over 58%. So these are our precursor chemicals. If we look then to how these materials are used, we have to put them together in a single compound. And so the process that we're going to go about doing this is a process of co-precipitation. In the first instance, we will dissolve the sulfate materials and then we will convert them to hydroxide. So if we look at the process in general, we have to make sure that our ratio of metal sulfates is the desired stoichiometry, but it's a fairly simple process of dissolution in deionized water. The process of converting these materials, these dissolved sulfates, then into hydroxide, is a process of precipitation by adding precipitating agents such as sodium hydroxide and ammonium hydroxide. The reactions themselves have to be quite carefully controlled in vessels with controlled atmosphere, concentrations, temperatures, stirring speeds, etc. But when the precipitate is formed, It's a simple process of washing and drying. And then we have our hydroxide precursor. The hydroxide precursor then needs to be separately lithiated. So the dry hydroxide precursor powder is mixed with lithium hydroxide in a dry form so as not to destroy the initial morphology that we've created. We add dopants to enhance the property. And then the final stage of production goes through a calcination. 2 stages. So we produce the first stage at around 450 to 480 degrees, around 5 hours under flowing oxygen, and then we move to 750 degrees C. So the final cathode active material goes through these stages of development, but these are sort of stages of production that are quite well known. These are the sort of stages of production that are quite capable of being done on site in WA. So as I said, I'm just giving you a brief summary of the report, but there are some key takeaway points that I'd like to discuss, and this is that this research was commissioned to investigate economic feasibility and supply chain requirements for lithium-ion battery precursor manufactured in WA at industrial scale. That's quite important. So the other thing which Peter Klinken alluded to was that Australia currently produces 9 of the 10 mineral elements required to produce most lithium-ion battery anodes and cathodes. And it has some commercial reserves of graphite, the remaining element, even though we may be able to synthetically produce that in WA as well. The NCM cathode active material is particularly high relevance to electric vehicle market, which is emerging very rapidly. This material is serving about 53% of the market in 2019, and it's predicted to grow significantly. So this report recommends a gradual ramp up of NCM cathode active material from a lab scale up to plant production. The report provides a state-of-the-art technical assessment or a blueprint on how this might be established in precursor manufacturing in WA. But importantly, it also looks at and confirms the technical and commercial feasibility for cathode active material precursor to be manufactured in Australia and in WA. I'd like to acknowledge my co-developers of this report, in particular Dr. Josh Watts, and our supporters through the Future Battery Industry CRC, Minerals Research Institute of WA, Hatch Engineering, QUT, and Curtin University. Thank you.
Thank you, Peter, for taking us through the summary of your report. That was a fantastic way to get across the detail and the findings that you've arrived at. Of course, the full version of that report is available on the FBICRC website, and I'd encourage people online to take a look at it in more detail later. Gary Frampton, as Head of BHP Nickel West's Head of Business Development and Technical Projects, you're obviously eyeing off the commercial opportunity that presents itself in this space. I'd be really interested in your insights into this report.
Great. Well, thank you very much, Miriam, and thank you, Peter, as usual, for a very succinct and excellent summary presentation. And also, good day to Peter Klinken. Good to catch up again. Thanks for the opportunity of participating on this panel. To us, it's such an important topic, and from an industry perspective, it's a really exciting project for us to be involved with. On behalf of the industry participants, I believe that WA is extremely well placed to develop battery precursor production capability, which is central to the downstream processing of these battery minerals. I think too that this has enormous potential to make a very significant economic, social and environmental contribution to WA and to the nation and to the world. And it certainly places Australia at the forefront of being an exporter of value-added products rather than just the raw materials that we're used to presenting. So to reiterate some of Peter's comments, we have 9 of 10 of the critical raw materials for the battery supply chain here in WA. And the bottom line is that as industry participants, what we're looking to achieve here is the key driver is to increase earnings. And so there are 2 ways to increase earnings and create value for shareholders. The first way is the obvious way that we used to expediting in Western Australia and Australia, and that's to grow our volumes. And the reason for us looking at this as being probably the easier of the two options is that we're blessed with a fantastic commodity resource and reserve base. So that's an obvious way for us to go. But the second way to do it is the interesting one, and that's to not just think about increasing volumes, but actually to think about increasing margins. And to increase margins, there's the optionality of actually looking at going further down the value chain for these commodities. So this particular project that we're having a look at here is to establish the viability of precursor manufacturing in Western Australia. And what this project will enable us to do is to explore as an industry and as a research team with the various universities to explore different options for selling a completely new suite of chemical products that are further downstream in the industry, and thereby increasing the margins so that we can move from, I guess, from being a commodity supplier to effectively a downstream producer. In the case of BHP as a good example, we have a good foundation for further vertical integration. So in our assets themselves, we have moved from being a concentrate producer to being a matte and refined metal producer. Our initial mandate for probably the first 45 to 50 years of our life here in WA was to provide nickel units for the for the stainless steel sector. And clearly there's a new megatrend that's emerging, and it's a great opportunity for us to completely reorientate our business and to have a look at supplying nickel into this megatrend for the battery raw material supply chain. It's a huge megatrend, and in fact in the past probably 3 to 4 years, we've moved to selling 100% of our products to the London Metal Exchange, to effectively over 70% of our nickel products now going into the battery raw material supply chain. So quite an exciting change to what's happened in our industry. And as I said, we've got an opportunity to go further down the margin journey. We've made a decision to manufacture nickel sulfate. We're currently in construction, hoping to complete a nickel sulfate production facility in terms of practical completion by the end of this year. And that will enable us to become one of the world's largest suppliers of nickel sulfate as a chemical and move further down the battery raw material supply chain. What this cathode precursor pilot plant flagship project from the FBICRC will enable us to do is, together with the other industry participants, continue to explore the option of adding even further margin and going even further downstream. And I actually think we've got some wonderful opportunities and there's some fantastic reasons for us to be successful. So just trying to summarize that in a very short space of time, we own the commodities here in WA, so let's take advantage of those commodities. We're blessed with fantastic resources. Second reason is that we've got huge pull development requirements from the battery supply chain itself. So car manufacturers are approaching WA companies, battery manufacturers are approaching WA companies, all trying to get that market up. We've got a talented pool of resources. So we've got fantastic engineers, frontline operators that can take advantage of this. We've got significant industry participation in this project. There are over 11 companies that are working on this particular project. We also have fantastic state government and research participation in this organisation, in this particular issue. You couple that together with the fact that we're uniquely placed here in Australia with an ethical and sustainable footprint that is unparalleled anywhere else in the world, and we're blessed with a very stable geopolitical and reliable jurisdiction over here. So I think we're really well set, Miriam and Peter, to take advantage of this opportunity. And as an industry, we're incredibly excited. So I'll hand back to you.
Thank you, Gary. That's a great summary. Really appreciate your thoughts on the research to date and also the future projects to come that focus on the cathode precursor pilot plant. I would encourage members of our audience online to ask questions if you would like to post any. We're about to now move into some of the questions that we've received, but we'd love to hear more from you. Gary, I might just bounce back to you first. The first question that we received has actually referred to the need to bring foreign firms onshore to Australia to aid in the development of the battery value chain. What do you think we need to do to attract foreign firms to Australia to help with that?
Yeah, great question. Look, I think the key thing here is to actually make those foreign firms see a compelling business case. That would be the most logical thing for us to do, and there's some great opportunities to do that. So I think 4 areas that I would have a look at is introduce them to the market capability within Australia. So, whether there's opportunities for us to have a look at development of battery materials for the mining industry, for a very, very diverse population set that may require battery materials in rural and that sort of setting, I think is a great opportunity. And in fact, in some of our defence applications, because we've got some very high temperature applications. So there's some great opportunities to actually realise a compelling market case here in WA. But in addition to that, from a production side, there are some huge cost and scale synergies of actually going further downstream in Australia, because we have quite a bit of infrastructure already. So we've got some vertically integrated supply chains, and we have the commodities on board over here. And it's important to have, if you've got commodity streams, to have co-location of those downstream products with the commodity stream. So I think that's a very compelling business case for the battery suppliers. The third point, or maybe the fourth point that I would raise, is that the sustainability credentials of Australia are almost unparalleled. And so, we're seeing increasing focus. In fact, our marketing teams, and I'm aware of similar stories in the manganese space and in the lithium space and in the cobalt space, where the marketing teams and the operators are being approached almost on a daily basis by that battery material supply chain to ask them whether they can provide a sustainable and an environmental source of these commodities. So the case, I think, to attract foreign terms is very compelling off those bases.
Thanks, Gary. That's really great. I'll turn now to Peter Talbot in Queensland with a question that's come through about the synergies in global supply chains. This is someone thinking a bit bigger than just batteries and looking to other batteries and other metals and minerals that are used for things like wind and solar. So the question is, are there synergies with global supply chains, Peter, with Japanese conglomerate manufacturers, for example, across battery metals and other metals, particularly for use in the renewable sector, that could help us pinpoint the best partners that we could attract for a significant amount of funding?
Okay, thanks, Miriam. I'd like to point out, I guess, just at the beginning of that question, that Australian researchers and industry have been working with batteries and battery development for many years, and therefore have quite good world-class expertise in that area. As a result, we have great connections and networks across the world. And so when the FBICRC sought to set up the Cooperative Research Centre, they invited those global partners to be part of what we're doing. So in terms of the question about do we have synergies, the answer is yes, and so much so that some of our participants, our core participants, are from overseas, from those conglomerates. And an example would be BASF, the world's largest chemical manufacturer, is a core participant in cathode active manufacture project in WA. So we've looked to our partners overseas and our connections and hooked into the international scene to provide the best outcomes that we can here in Australia for manufacture. In the second part of that question regarding other metals, there's very strong and interesting developments in Australia around vanadium redox flow batteries. The redox flow battery was developed at the University of New South Wales. It's an Australian invention. It's quite an opportunity as well. The CRC is quite interested in that opportunity. And there are major miners in WA and Queensland which can take advantage of those deposits in terms of an alternative battery type. So across this sector, 9 of the 10 elements are there in WA, but we're just about working through the rest of the periodic table in terms of the sorts of things that we might be able to do.
Can I just add to that a little bit?
Please, yeah, Peter.
Thank you. Look, I think all of those opportunities are fantastic, but there's another one that I see which involves other critical minerals such as the rare earths. and the rare earths are involved in producing wind turbines. So it wouldn't be fantastic if you could actually be manufacturing wind turbines as well as the batteries that are required to store the energy. So I think there are synergies in all of the elements that are present here in Western Australia.
Thank you, Peter.
I think just as a small addition, at the moment, most of the EVs use the rare earths in the motors. And so the energy we store in the batteries goes straight on to be used in that way.
Yeah, that's right. Thank you. One of the other questions that we've received is about green electricity. So it hasn't really been mentioned yet, but there's certainly a thought that the incentive of having green electricity available may be enough to attract foreign partners to invest in plants to produce anode and cathode materials, or even cell manufacturing. Peter Klinken, what do you think of that?
Well, I think it's an increasingly important component in these conversations. As Gary alluded to, the world is really approaching this with a different lens. We're looking to source things ethically and as renewable as possible. But cheap electricity, reliable electricity are also crucial elements in all of this. So we have to make sure that it's not just green, but it's also clean and it's also reliable and cheap.
Indeed.
Can I just maybe add to that, Peter? I think it's not only an incentive for people, for foreign partners to look at Australia. It's actually becoming quite an imperative. And so we're seeing, for example, the London Metals Exchange with their responsible sourcing initiative, the International Council for Mining and Metals with its mining with principles sort of focus, the EU battery directives is another example, all insisting on high levels of provenance, and the requirements are now actually getting quite strident. And I do think that there's a perception out there that Australia are incredibly well positioned to take advantage of that point because they have those credentials and are endeavouring to build on those credentials more and more.
Thank you, Gary. Another question. No, Peter Talbot, would you like to contribute there?
There is another area that's emerging, if I can say, Miriam, in regards to complementary technologies of energy storage. An example would be, wouldn't it be fantastic if we could export our sunshine? But we need to store it first. So if we're storing a solar, renewable energy in batteries, we can also use it for production of hydrogen. So the hydrogen then is an additional export product, and that way, in this way, we can use the complementary technologies of batteries and hydrogen storage to have additional export markets.
Thank you. Yeah, that's a great point about the establishment of one emerging industry becoming a catalyst for a hub of other emerging technologies and industries. So well made, thank you. Peter Klinken, there's been a question come through referring to some of the incentives that other jurisdictions are offering to attract battery manufacturing and recycling to their areas. The EU in particular has been mentioned, a number of country-specific efforts in Europe. How do we compete with that beyond what we've already talked about as WA and Australia's general benefits? How else do we compete with significant incentives like that?
I think we play to our strengths. We've got all the elements necessary here. As Gary has alluded to once again, we're ethically sourced, we're incredibly well regulated, we're stable. All the elements are here necessary to be incredibly successful in this area. We do have lots of space. I can't see why you wouldn't do it here. That's my bottom line, actually. You're the expert in business. What would you say, Gary?
What I would also just add to what you've said there, Peter, is that we don't necessarily need to go over the top in terms of support. This is after all an industry, and so what we are starting to see is we don't necessarily need to compete with largesse. We're actually just got to interact with that battery supply chain in a logical and considered way. And as I flagged to you, each of the industry participants that we're working with here are engaging on almost a daily basis, and it's because they see the value proposition. So it doesn't necessarily always have to be promoted and subsidised, and we might not have to compete with the largesse. Just work with the customer. That's the critical issue.
I think you raised a very important point earlier around hubs. and having complementary expertise present. And we do have that here in Kwinana and Kemet and, in Kalgoorlie. So, once again, you're building on capabilities, aren't you?
Actually, I will just keep going with that theme around skills and the hubs. We have another question come through. Gary, I'll ask you to respond to this first. What skill sets and training are most desirable by industry for graduates who want to work in the battery sector?
Yeah, that's a great question. A skilled workforce is so important to this and many other industries, but to develop a world-class battery material supply chain industry here in WA, we're obviously going to need to have a world-class workforce. And so traditional roles like chemical engineers, other specialist engineers, metallurgists and operators are going to be really important for us to develop that skill set. I did want to call out, though, the front line. It is important for us not just to focus on the technical skills, it's also about the front line. So roles like process operators, process technicians, laboratory technicians, electrical engineers, we're going to have to change our mindset. We're now moving from a commodity sort of focus to a refining sort of focus, and even going further downstream than that, where we're now looking at value-added focus and moving from effectively a resource company into a chemicals sort of company. And so that's going to need a bunch of different skills. It's going to need quality control. Have I got the right precision? Have I got the right reproducibility? Have I got the right consistency of my products? So we're going to have to develop that sort of skill set. We're going to have to start working really well with automation. Most of these processes are pretty automated and have got a lot of technology smarts there. The third ingredient is that clearly we still want to maintain our focus on safe handling. Some of these downstream processes have got quite sophisticated usage of bulk and hazardous chemicals, so we need to see that focus develop as well. The good news, though, I think, is that the Future Battery Industries, CRC, have been working together with a couple of the local TAFEs, as well as the more traditional university tertiary education systems. So the South Met TAFE have been doing some fantastic work. I think it was actually commissioned by the Department of Training and Workforce Development here in WA. And what they've actually done is they've looked at what current courses are available, and they've done some curriculum mapping of the skills requirements for those roles versus what these requirements are going to be like in the future. And what they're doing is they're going to be ensuring that the right skills are taught in the right courses to the right people. So I think we've made some really great progress on this front already.
Can I follow up on that?
Please.
The state government introduced a campaign called Take Two for STEM. And the idea is that kids in Year 11 and Year 12, 85% of them take 2 science or mathematics subjects in the final 2 years of school. And that to me is really important as the lead up into these opportunities in tertiary education, be it in the vet sector or in university sector. Because if you have that core base of people that have all the necessary skills, they take that to the next level, and now you're seeing these new opportunities. So it's an exciting time to make sure that we do have the workforce of the future.
Thank you. Indeed, the flow-on effect from establishing this industry in WA and Australia more broadly for jobs and employment for future generations is not to be underestimated. Before I throw to another question, Peter Talbot in Queensland, did you have anything that came out of your research regarding the skills required and whether they're already present in Australia or need to be developed that you would like to add?
I think one of the issues that came up with the quantum of skills and engineers, etc., that we're actually going to need to educate. If we look at the full sector that could potentially grow from the development of the chemical end of the resource sector, it extends all the way up and through the value chain, and this is part of the Future Battery Industry CRC's role, is all the way up into application. And so as we build the foundation industries, the other industries will follow. And so we're looking at the full value chain here, potential. An early slide I put on showed just how much value there is all the way through that. But we're up and we move from chemical processing into automation, into electronic and into large-scale power distribution. I think it's an enormous opportunity for Australia.
Yeah, agreed. Thank you. We've had a question come through from one of our members of our audience regarding competition with Southeast Asia on cost. Gary, you have touched on that, and you've also been mentioned already the premium that you're seeing people being prepared to pay now for ethical and responsibly sourced minerals. I think I know the answer to this, but I'm giving you the opportunity to comment further. Can we compete on cost with Southeast Asia? And is the ethical premium, is everyone prepared to pay that, or enough people prepared to pay it to make this an economical industry for us?
Yeah, I think it's a great question. I'd like to hear from the other contributors in in the panel, but I'd like to make a start perhaps. And I think there are two reasons why we can compete with the Southeast Asia sort of market. The first reason is scale. So when you have the commodity base, resource base that Western Australia has, we can produce these precursors, or this nickel sulfate, or these nickel units, or the manganese units, or the lithium units at huge scale. And so, you know, while you can have a niche operation in Southeast Asia producing quantities at a certain cost, you've got the scale opportunities here in WA to leverage off. And I think that is an enormous opportunity for us. The second one is that when you co-locate downstream processes with the vertical supply chain as you already have it, you have enormous opportunity to consolidate that supply chain and remove unit operations. And so, for example, one of the things that we are attracted to about the option of looking at precursors is that right now we produce a nickel sulfate, or we will be producing a nickel sulfate, which is then transported overseas. Imagine not having to crystallize the nickel sulfate. So you remove an expensive unit operations. You then have to transport that nickel sulfate overseas, take a liquid nickel sulfate stream and put it straight into a precursor plant. Save the unit operations, save significant cost. So I think there's a couple of opportunities there for us to leverage off. I'd be interested in the other views.
Peter Klinken, what say you?
Oh, look, I'm just a geeky scientist. You know, I get excited by all of this. I don't have the economic wherewithal to be able to make a worthwhile contribution apart from saying, let's just do it.
Sorry, I might just jump in on one more point. I forgot to answer the second section, which is would people be prepared to pay a premium? I don't think we should rely on that. I think it should almost be a part of the way that Western Australia and Australia does business. And if that premium ultimately materialises, that'll be fantastic. But at the very minimum, what it'll do is it'll ensure that we are the supplier of choice.
Yeah, great point.
Good point.
To any of the panellists, I'd put the question, are we seeing the preparedness to pay a premium for ethically and responsibly sourced minerals in any other commodity sector at the moment? Does anyone have any comments around that? Because it's spoken about often. Do we have a track record there? Peter Talbot, Queensland?
I think that we've seen in general this become a factor in the development of the EV, particularly companies like Tesla, etc. overseas, have moved strongly away from materials such as, let's call it, is it unethically sourced cobalt, if you like, from different regions of the world. So much so that even if, because of cobalt has high performance, they'll move away from that into other compositions. Now, if, as Gary has pointed out, you know, it's possible to recover and use that cobalt, or, you know, from processes that he's already using, I think that you'd find that there's a great market for that here as well.
Thanks. That's a great example. Sorry, Peter, keep going.
Well, in general, I think that the opportunities keep presenting themselves. If you look at something like the question was about Southeast Asia, but the ASEAN region itself is over 650 million people that are looking to Australia as a leader in developing renewable energy. So it's not just our resources, it's our capability, and a huge market on our doorstep there.
Great point, thank you. Another question we've just received is a great one and probably expected, about red and green tape. So our audience member has said our biggest value add multiplier is in the ore to precursor conversion step, but that red and green tape slows us down versus our competitors outside of Australia. And we often see risk aversion in Australia, leading to international acquisition of Australian opportunities. What can be done?
I'll take that one.
Thank you, Peter.
Look, I think this is a unique moment where Australia is actually having a very good hard look at itself. We're a very well-regulated country, and some might say too well-regulated at times, and that results in red and green tape. Having said that, though, there is an appetite I see at the moment to reevaluate all of that, to make sure we still do have very, very rigorous regulatory systems, but not to impede progress. And I think we're seeing a change in vision. We're seeing a change in the narrative around how we want to make things happen. And so there's a change in emphasis to go, well, you know, we're more than a rocks and crops economy. We do more than take big rocks, turn them into little rocks and put them on a ship. We can do a whole lot of sophisticated processing and going downstream as well. I think this is a serious new conversation that's happening right now, and I'm confident that we'll see improvements in that area.
Thank you, that's great. Gary, obviously, is from an organisation that deals with a lot of red and green tape. I'm sure much of it, if not all of it, you know, considered to be necessary for all the reasons that you cited earlier about our natural advantages being a stable geopolitical place to operate and to have the strong environmental credentials that we do. Can you see opportunities for improvement there to improve our competitiveness?
Look, there's always opportunities for improvement, but to your point, the exact reason why we have the credentials we have is because of some of that red and green tape. But we're seeing in the industry, certainly here in WA, quite a concerted effort to try and remove red and green tape. And so, for example, the battery task force that the Premier has instituted is looking at opportunities to short circuit some of these things, and with the support that we've got out of numerous government departments over here have been really excellent in helping us to navigate some of these issues. So I think there is a bit of work being done as well to address the issues.
Thank you. That's, we have one last question. Is there any parameter to ensure that the battery construction from current manufacturing will make them easier to be recycled? Great question, actually, very future facing, thinking about the life cycle of these materials. Peter Talbot in Queensland, do you have any thoughts on this one?
I think it's the FBICRC has recognised the importance of recycling, and so have our participants and our core participants, and that comes through their cash support, their in-kind support, but it's made our recycling project one of the largest projects that we have in the CRC. It's recognised here in Australia as well as in Europe that it's going to be an absolutely necessary part of what we do. So how the batteries are constructed, how we'll actually go and do that recycling, it's the full life cycle of the battery that is being considered. So it's at the core of what we're actually trying to also achieve in the future battery industry CRC.
Could I just add that there are companies in Western Australia at the moment that are already engaged in recycling, and so they are at the forefront of this.
Thank you, that's great. We're just about at time, so I will just turn to each of my panellists and ask them for some closing comments to sum up before I thank everybody. So thank you for all the questions that have come through. Gary, if I could perhaps start with you. Any closing remarks where you see the next phase of research heading?
Well, we're excited about the research. We're excited about this flagship project, and we see WA being really well placed to develop a battery precursor production capability, which will be exciting for companies, it'll be exciting for research organisations, it'll be exciting for the state, it'll be exciting for the nation.
Thank you, really positive. Peter Talbot, as the lead author on this report, how would you like to summarise your hopes for where it goes from here?
Well, I'm very optimistic that Australia's coming of age in terms of its manufacturing and downstream processing, and the support from WA has been fantastic in this area. Through the CRC, I've found that the CRC is a cooperative research centre, and the cooperation between all parties across Australia has been amazing, fantastic. We're finding that all states are participating, over 70 companies participating with government and our other research organisations. And so, as I said at the beginning, I think we've come of age where we can actually go forward confidently, and hopefully this report is a starting point.
Thank you, Peter. And Peter Klinken, what are your final thoughts?
Well, I think this is probably the first time as Chief Scientist I've had someone who's more excited than me. Gary, I loved the fact that you said 7 times that you're excited. Right? I am, because I just see that Western Australia and Australia as a whole has this unique opportunity right in front of it now. You know, if we play our cards right, we will be setting up this nation for the next 50 to 100 years, in my view. But if we don't, future generations will look back and go, how did you miss that opportunity? So we really must make the most of this very, very special moment in time.
Really, really important point, thank you. My take on it is that I hear a lot of naysayers saying that downstream processing will never be viable in Australia. We don't do it, we're not cost competitive. We're certainly hearing from 3 different people in different industries that that's just simply not necessarily the point, and there's a lot of different ways that we can find our competitive advantage. So I thank my panellists for sharing their different views. It goes far beyond just the natural and large endowment that West Australia and Australia more broadly has in these minerals. And we've heard about the synergies that we're seeing or can see from co-locating facilities, such that we can remove unit operations and therefore actually improve the economics of some of these processes. We've heard that we have a skilled workforce and an upskillable workforce present in Western Australia to support the very many different types of roles that will be needed to support and grow these industries. We obviously have a stable geopolitical environment and are very supportive of investment, which is critical and not to be taken for granted. There's an appetite for regulatory appropriateness, so that red and green tape is there for a reason, but not stymieing the efforts of industry. And of course, the moment in time now, why it's so important that we do capitalise on this opportunity is because of the market demand for these minerals. I've been so impressed with the collaboration that's been driven by the FBICRC from all areas of government, a number of research organisations and universities, and the private sector to capitalise on this opportunity. I think it's fantastic, and I'd like to congratulate the FBICRC for the work that they've done there to bring this together. This is the first online public event that the FBICRC has offered, but there are many to come. So I would encourage members of our audience to check out the website, not just for a recording of this event, which will be posted in the next couple of days, but also for notifications of future events that we'll be holding in order to share the outcome of future research projects that are underway. The FBICRC has another 5 years to run and a really fascinating and diverse pipeline of projects underway. So please do stay in touch and make sure that you can attend as many events as you can. Finally, I would like to thank our online audience for being prepared to attend online. It's a different environment we're working in, but we hope that you found the format of this session to be informative and useful. Thank you also for those of you who posted questions. It's really great to get the interaction. Even though we can't see you out there, we really appreciated your input and your responses. Thank you to the FBICRC for arranging and hosting this event. And I would also like to finish by thanking my fellow panellists. So Professor Peter Klinken, thank you very much.
Pleasure.
Gary Frampton from BHP, thank you again for all your comments. And Professor Peter Talbot from QUT and the author of this report. Thank you very much.
Thank you.
Goodbye everyone, and thank you for attending.